We're going to start chapter 7 today. Chapter 7 deals with, we've just looked at simple organic compounds, alkanes, alkenes, alkynes, carbon, hydrogen. That's it. Well, what if we take off one of those hydrogen, we add something else? We're going to throw in some oxygen, some sulfurs, the halogens, bromine, iodine, chlorine, fluorine, those kind of guys. We're going to put some other groups on there. And the system is relatively the same as far as naming them. You count the number of carbons and so on. But we're going to look at all kinds of different groups that we're going to throw on our carbon compounds. Okay, the first one we're going to look at are called alcohols and esters. This is an oxygen or an OH. An alcohol is hydroxide, OH. Okay, the functional groups come from water because if you think really water is HOH. Okay, one hydrogen is replaced with a carbon to form an alcohol. So basically, you take off a hydrogen and you add an OH group. And again, OH is an alcohol. Both water molecules have the bent shape. Like if you remember, when you draw water, you have oxygen, two lone pairs, two bonded pairs. So its overall shape is bent. So you get this, like this one would be 1, 2, 3, 4, 5, and then an OH group on the end. Okay. So they're going to have the bent shape there, but we'll go through the rules of actually naming them, which isn't that difficult. But again, you're going to count the number of carbons. That's important. That comes up in the name, just like we did with all the rest of them. Okay, so there's actually 3 different types of alcohols because you can have more than one. Okay, if you have an OH group, one R group, that just means like it's your methane, your propane, your whatever, and 2 hydrogen. You can have a secondary where you actually have 2 OH groups, okay? Or you can have what they call a tertiary, where you have 3, all right? We're not going to spend a ton of time on this. I'll show you how to name them, and that's the big thing we're going to deal with. But this is going to be an alcohol just ends in OL. If it's 2 of them, it would be diol. If it's 3 of them, it would be triol, okay? So you can see down here, you have a group with an OH, you have one with 2 groups, you have one with 3 groups. And again, or we can have more OH groups. Okay, and again, I'll show you how to name those here in a second. Okay, so when you're going to name an alcohol, again, you sign the root, you look for the longest carbon chain. Count the carbons. Okay, assign the ending. Okay, if it's an alcohol, the ending is OL. If the chain has more than 2 carbons, again, you have to say where it's at, okay? So if the OH is on the end, which actually becomes the beginning because you want the smallest numbers, you don't have to worry about to put a number in there. But if it's not, if it's in the middle somewhere, then you've got to say, it's on the 2nd carbon, the 3rd carbon, or so. Just like we did with substitute groups, methyl groups, ethyl groups, propyl, all that stuff. Same rules, okay? So if it's on the and, which actually becomes the 1st carbon, you don't have to write a number. But if it's anywhere besides the 1st one, you got to write a number. Okay. And then if it's on a substitute, it ends in like we did before with the alkyl. So if you have methyl groups and propyl groups and all, you still have to name them. So nothing gets wiped out. We're just adding more rules to what we already knew. Okay, so look here. We have 1, 2, 3, 4, 5, 6. 6 carbon. That's hex. The AN tells me all single bonds. Okay, and then actually I'd put the 2 in front. This book varies. I don't know why it does that, but sometimes it's in the front, sometimes it's in the end. We'll just put it in the front. It would say 2 hexanol. I should have probably changed that. Sorry about that. Okay, the only time I would put it over here is if, let's say there was a double bond here. Let's say there was a double bond right here. I'd say 3 hexene 2-ol. Okay, so, and again, if there's nothing else going on, just put the in the front. Okay, like here. Okay, we got 1, 2, 3, 4, 5, 6. Same thing. And here's it's on the 3rd one. 1, 2. So that would be 3rd. And then it's 6. And then we got a methyl group here as well, right? So 1, 2, 3, 4. So we'd say 4 methyl. And then this is 6, so that's hexanol. But we got to say it's on the 3rd one. So again, here's my methyl group. It's on the 4th one. And my OH is on the third one. And then you drop the, it would be ANE. Instead, it's going to be ANOL. So drop the E and put OL. Okay? We got to leave this in here because it's all single bonds. So some people want to write HEXOL. Don't do that. Leave everything, just drop the E and write OL. And that tells me there's an OH group on the third carbon. And on the fourth carbon, there's methyl. As far as numbering, you guys, you want these substitute groups with the oxygen, all that. They take precedence, so you want them to have the smaller number. That helps you when you're trying to figure out which way to number. Okay? Okay, here's another one. 1, 2, 3, 4, 5, 6. We got 2 OH groups. Okay, and then we got a bunch of methyl groups. Okay, we want this to be number 1 here. So 1, 2, 3, 4, 5. Okay, so we know we have 5 is pent. Okay, all single bonds, penta. And now we have 2 of these guys. So we got to say where they're at. Plus we got all these methyl groups. So let's see. 1, 2, we'd go 2, 2, 4. The second and the fourth. 2, 2, trimethyl. Okay. And then we got our 2 OH groups on the first and the third. So 1, 3, and then it would be 5 is pentadiol. Okay. So 2, 2, and again, we want to number from this end because that'll give us the smallest numbers. 2, 2, 4. Okay, if I have a tri here, I have to have 3 numbers. If I have 3 numbers here, I better have tri. Okay, just because these 2 guys are in the same one, doesn't mean you just say write 1, 2. They're both there, so 2, 2, 4. Trimethyl, there's the fourth one. And then on the first carbon and the third carbon, there's an OH group. That's, again, penta, because it's all single bonds. Di, meaning 2 OH groups. Okay? So again, when you're naming them, the substitute groups you just name like we did before. Now we're just adding, if you have this OH, you just have to add OL. But if there's 2 of them, if there was 3 of them, I'd have where that number is 2, and I put triol. I don't think you'll see more than 3. Actually, 2 is probably the most you'll ever see. Okay? So another thing that's similar to an alcohol is what they call an ether. You've probably heard of ether before. It's the notorious thing that they knock people out with. They put it over their mouth and they immediately fade. It doesn't happen that fast, but they do. They used to use it like in surgeries, in like medical, like war, MASH units and stuff, because it will knock people out. But it does slow down your breathing. So they realize that it's a little iffy if you overdo it. I mean, you can kill somebody if you overdo it. Okay, but anyway, alcohols in nature and biochemistry, again, we said with 2 hydroxyl groups are called diols. And triols, we said that already. You can have some with many, like glucose. Glucose has many, the simple sugars. But anyway, we went through that already. I guess I already picked that. Glucose is what they call a polyol because it has, if you look at the structure, do I have it? Yeah. Here's glucose. Glucose is, the stuff that gives you life, the stuff that plants make through photosynthesis. And look at all the OH groups. 1, 2, 3, 4. And there's another one here. So there's a lot of hydroxyl groups. That's why it's called a polyol. But again, we'd probably just do, 2 would probably the most we would do. But again, you just put the name in there. Actually, they just call this glucose. So we don't have to worry about calling it and coming up with the whole name. Ooh, that would be a doozy, right? 1, 2, 3, 4 OH groups plus another one there. Yeah, that'd be a lot. Anyway, so if you have an alcohol that's added to a ring, like a hydroxyl ring, like a benzene, okay? If you put an OH group on that, you can also call it phenol, okay? An aromatic ring, so that would be benzene, and a hydroxyl act as one unit. They're actually different. They act different. Like if you have a chain with an OH group, like ethanol, it's way different than a benzene with an OH. They have totally different characteristics to what they react with and so on. So I guess they get different names. The thing with a phenol, and again, phenol is a benzene with an OH group on it. They readily lose their hydrogen from the hydroxyl. And so they give you antioxidant characteristics. They're antioxidant. We know that ties up free things. Is supposed to help prevent cancer and all these other things. But I wouldn't suggest drinking phenols. But they do have some properties like that, okay? So if you're going to name this, the root name is phenol. So let me see. This right here would just be phenol because it's benzene and you have an OH group. So now it just becomes phenol. And again, I know that's weird because you think it would be like benzenol. But remember when we had it as a substitute group, when this was a substitute group, it wasn't benzyl, it was phenol. So same thing. I promise you guys, I didn't come up with the rules. I just have to follow them. Okay, this group, okay, we have 1, 2. Here's an ethanol already. Okay. Okay, and this is the group. This is the main chain. This is stuck on it. So remember, this is a phenol. Now where you're like, well, that's not the first one. It should be 1. No, the OH takes precedence. So because I don't have a number there, I'm saying it's on my first one. So if this is the first carbon, this has to be the second carbon. So that's why it's 2-phenyl ethanol. Okay. So again, if you have an aromatic, if you have a benzene ring, it becomes phenol. Oh, here we go. Now we finally got the esters. I started talking about them and then, okay, esters are named for what an ester does is it basically breaks 2 groups. You'll have like a methyl group here and an ethyl group, and you'll have an oxygen in the middle. That's what an ester is. Okay, they're very unreactive, so they use them as solvents a lot because they don't break down. Okay, and again, like I was telling, small esters, ether, they oh, there should be another E here. Sorry, you guys. Have been used for anesthetics. They just got to be really careful because if you overdo them, unfortunately, you'll kill the person. They do suppress your breathing. Okay, so when you're naming an ether, each group on either side of the oxygen, you give it as a substitute group. So it's like oxygen in the middle. Each group is going to be a substitute. So if it's a 4-chain, you're going to call it butyl. If it's a 2-chain, you're going to call it ethyl. And then on the end, you add the word ether. So, and when you're doing, again, substitute groups, you got to go in alphabetical order. So here's my oxygen in the middle. The oxygen breaks up the chain. So this group is a methyl, and this group is an ethyl. So I'd name this ethyl, methyl, ether. Okay? So you name each group as a substitute groups, and the ether tells you there's an oxygen in the middle. Okay? This one, here's a methyl group, and here's 1, 2, 3, propyl. So alphabetical letter would be methyl, propyl, ether. Okay? This is my favorite to say because, okay, we got an oxygen in the middle, so that's the ether. These are 2 ethyl groups. So instead of saying ethyl, ethyl, you can say diethyl. So diethyl ether, that would not be an easy thing to say if you had a speech impediment, wouldn't it? I mean, organic chemistry, they never took in account people with disabilities, I swear. But anyway, diethyl ether, you got to admit that's kind of fun to say. So it's not ethyl ether, it's diethyl ether. Okay, and again, you got the oxygen in the middle and you got the groups. So you just name each group. Now, if there was a substitute group here, you'd put that on there too. Okay. If we're going to look at the physical properties of alcohols, phenols, again, that's benzene and ethers. The alcohols are really good at forming hydrogen bonds. The ethers, not so much. They're not very reactive. Okay. Alcohols and phenols have much higher boiling points and their molecules tend to be larger. Okay. Ethers interact, they have dipoles, but remember, hydrogen bond is a stronger bond. Okay. But because they have a weak polar carbon oxygen bond, then they don't stay together as well. So ethers is not nearly as strong. They're a little bit more, the small ones are more stable. As you get bigger, they are not very stable. They fall apart. Okay. So ethers have lower boiling points than alcohols of the same size. But if you look at an alkane, which is just a simple one, they're more together. In other words, they're a stronger bond than an alkane, but they're a weaker bond than an alcohol. I guess that sums up the statement. Okay. So your alcohols and your phenols, because they have those hydrogen bonds, remember hydrogen bonds is the strongest bond in between molecules. Okay. It's the strongest intermolecular force. Okay. And ethers are next, and then your alkanes would be the smallest. And we're out of time. So we'll hit up another substitute unit, but we're going to practice alcohol and esters first.